If you're a little bit below the average, that's probably a C. So it depends where you're going to get. But so let's say maybe I decide that A's get cut off at the upper 16%. So I need to know the Z-score that goes with the upper 16. So how do we do this? Well, again, what I want to do is I want to draw this up. But the one difference here with this one is I'm looking for a Z that goes with a probability. In these problems here, what I was looking for was the probability that went with the Z. So I said, what's the probability of being between 0.96 standard deviations below and 1.01 standard deviations above? Now I'm asking, what's the Z-score that goes with being in the upper 16%? So what I want to do is I want to put this down. I'm going to call this ZU16 for upper 16%. Okay? So it's the Z-score that goes with the upper 16%. So U16 is that. And what I want is I want this area above that area to be 0.16. So I have ZU16 for the Z-score that goes with the upper 16%. I want the probability above that, in this case, to be 0.16. Well, I know the area above 0 has to be 1/2 or 0.5. So I know the area all above 0 is 0.5. I know the area above Z is 0.16. So the area between 0 and that Z is 0.15 minus 0.16. Or in this case, 0.34. So if I'm looking for the upper 16%, what I know is that the area between the mean of 0 and the Z-score that separates out the upper 16% has to be 34%. 50% minus 16%. And so what I want to do now is I know that the area between 0 and the Z-score is 0.34. And so what I want to do is I want to look for 0.34. Now, every test, if I ask a question like this, one thing that students do automatically is they go to 0.3, go across to the 0.04 column. That's going to give you a wrong answer. What you're looking for is the 0.34 in this case is a probability. In this case, the probability of being between the mean of 0 and the Z is 34%. So what we want to do is look in the middle of our Z chart for 0.34. So we want to look in the middle of our Z chart for 0.34. If you start looking for 0.34, you don't find 0.34 exactly. Okay. What you find is you find 0.3389, and you find 0.3413. So you find those two figures. You find 0.3389, you find 0.3413. And what you want to do is you want to pick the one that's closest to 0.3400. So in this case, that would be the 0.3389. You're picking the one that's closest, so it's a little bit closer. And then what you do is, okay, here's 0.3389, so you go across, you find that it's in the 0.9 row, it's in the 0.09 column. I didn't actually plan this out, but this is okay. or in this case, I find a z of 0.99. So to be in the upper 16%, I need to be 99/100ths of a standard deviation above the mean. So that's why, for example, when I was talking about the curve in this class, I was sort of saying, well, if you're about 1 standard deviation above the mean, that's probably about where I cut off A's at. Okay? So in this case, if I want to have about 16% A's, which is, if I do a curve, about where I want that at, okay, then you need to be about, on average, 1 standard deviation above the mean. If you average about 1 standard deviation above the mean, you're right at that cutoff of where an A or B would be. Any questions about this? This might actually help you explain the curve a little bit more, I think, in terms of if you want to think about where did you stand with that last test. Everyone feel okay about this topic so far? Well, let's take a quick moment. I have one more thing that I want to talk about, and then we'll be done, and then you can go off on spring break. Do any of you, is anyone, this is their last day before spring break? Okay. So actually you all are the losers up here in the front row. Is it, for any of you, is this your last class before spring break? There you go. Okay, that's nice. So, how many of this is your last class because you're skipping your next class? Good for you. So, yeah, so for some people this is getting close. I mean, you know, hypothetically, I could show to my 2 o'clock class. I could just show them a tape now. There's part of me that's a little tempted to, but I probably won't do that. Not sure. I might let them pick their lecture for that one. So what I want to do is one more thing, and this one is, so far we've dealt, I don't want to say in a nebulous situation, but I've talked about what's the probability of a z-score this or a z-score that. And that's all fine and good, but typically we don't talk about the world in z-scores. Okay? What we talk about is what's the probability of this. So maybe what I want to look at is So let's start off with this. Let's say the amount of time that a student spends online is normally distributed with a mean of 90 minutes and a standard deviation of 20 minutes. Or 25 minutes, excuse me, 25 minutes. So the amount of time that a student spends online has a mean of 90 minutes and a standard deviation of 25 minutes. Now this may not be accurate whatsoever, but we're just going with the example. So, we have this information. We think this is how students behave with the amount of time they spend online.